Hello students, this question is taken from test series 2 EE from the subject power electronics from the topic inverters, and it is of common data question for question number 50 and 51, and it is the first part of common data question, that is question number 50. In this given question, a three-phase inverter operating in 180 degrees conduction, which is nothing but this inverter, three-phase inverter is operating in conduction mode up to 180 degrees. Up to 180 degrees, the three-phase inverter operating in the conduction mode, and it is supplied from a 600 volts source, that is supply voltage is equal to 600 volt for a star connected resistive load of 15 ohm per phase, which is given. The load is star connected resistive load of 15 ohm per phase. The characteristics of star connected resistive load of three-phase inverter for the load current, that is I0, is this one. This we have to find the RMS load current. In this we have to find the value of RMS, that is I0 RMS load current. The characteristics of the star connected resistive load for load current, that is I0, is this one, having conduction mode up to the 180 degrees. For 60 degrees, the value of this one is Vs by 3 R, because the voltage here is supply voltage is Vs by 3 R, because resistor per phase, in this is 3-phase inverter, we had to take resistor value 3 R, and here the value of after 60 degrees, the value of this is 2 into Vs by 3 R. The value of this one is 13.33 and this one is 26.67. We know the value of supply voltage 600 divided by 3 into 15. R value is 15, the given question. Then we'll get the value of 13.33. Same thing here, into 2 we'll get the value of 26.67. First conduction mode up to the 60 degrees. After that it is 2 into Vs by 3R up to the 120 degrees. After again it conduction mode up to the 180 degrees in Vs by 3R and is in the non-conduction state. We had to find the value of I0 RMS. From the diagram we'll calculate the value of I0 square RMS, that is the formula to calculate the I0 RMS is equal to 1 by pi, that is conduction mode up to the 1 by pi of 0 to 60 degrees. Integration of 0 to 60 degrees of Vs by 3R, that is I square d theta, Vs square by 3R square into d theta, plus another conduction mode from 60 to 120 of 2 into Vs by 3R, 60 to 120 degrees into 2 into Vs by 3R square d theta. Then from 120 to 180 degrees it is of Vs by 3R. 120 to 180, the value of I is Vs by 3R square d theta. This is the formula to calculate the value of I0 square RMS. I0 square RMS. Then we know the value of supply voltage, that is Vs 600 volts and resistor given 15 ohms. 1 by pi will get the value of integration of this will become Vs square by 3 R square into 60 degrees, plus this will become 2 into Vs by 3R square into 60 plus Vs by 3R square into 60. Then substitute the values of supply voltage and resistor in this formula. 600 by 3 into 15. After solving this we'll get the value of, that is we have to find, that is RMS load current, that is I0 RMS is equal to 18.85 ampere. This is the value of RMS load current, which is option C. Option C. In this session, we have studied about how to calculate the value of RMS load current in a given three-phase conductor which is operating at 180 degrees conduction mode, and the characteristics of the three-phase inverter for star connected resistive load. Thank you.